Good morning, everyone. Sorry I'm a little late.
Good morning. Let's see, 3.8 movement. Whoops. Oh, facing. Okay. Just updated. Look at that. All right. Should I start with pull requests?
Sure.
Let's see. Hamai has one that changes the RocksDB interface to use the RocksDB range delete operator, which would help BlueStore in a number of ways. There are lots of places where we have to delete a bunch of keys and we enumerate them in order to delete them. And apparently it has sort of a remove range primitive. But there's a big fat warning in the header about how it's slower in some cases. So that's why I avoided it before. But I guess there's a bunch of activity upstream making that better. So that'll probably go in some form soon, maybe with the config option to guard whether or not we use the new thing or not. But I'm guessing it'll be a win. Let's see, there's a pull request from Radoslav cleaning up some stuff in the bit allocator and a bunch of other ones that merged last week also that fix up locking in the bitmap allocator and other sort of performance optimizations. Some of those have gone in and the other ones will probably follow soon. I'll just sort of clean up there. That's good. That's all for BlueStore. Also with BlueStore, there was a pull request that enabled processor accelerated CRC32 for RocksDB. That wasn't getting enabled in the build. So the Ceph CRC is optimized, but RocksDB's wasn't using the fast intel instructions. But that's fixed now, which speeds up the RocksDB stuff quite a bit, apparently. So that's also good.
For reference, I swear that we were actually using that at one point. That's
in
strange
RocksDB?
to me, but
or
yeah,
in
that was actually in RocksDB, like in the perf results, it looked like we were using the fast path. I don't know.
Yeah. maybe it broke when we switched the RocksDB build around because we went from using their native makefile to the CMake one maybe 3 or 4 months ago. It might have been broken then. Let's see. Sorry, you're going to say something, Radoslav?
Hello, Radoslav is speaking. I guess there is another possibility why someone could see such results in perf. This is because the slow because fast CRC has a fallback to slow CRC. There is basically there is check in the slow function in the fast CRC calculation function that calls the slow one. If compiler is inlining, that could be the reason.
That could be it. Okay, cool. How much of it speed up did you see as a result of that? Was it significantly faster?
It depends. It depends on use case. The most significant one is throwing a lot of data through RocksDB, like wall transactions, huge OMAP things, etc., etc. In such scenarios, there is I recorded around 30% bonus.
Awesome. That's great news.
That matches what I've seen in the past when we were using the slow pass too, because it was pretty significant.
Cool. Okay, well that's awesome. That's glad you noticed that. Let's see what else. A bunch of those other changes. We're also improving the memory usage for the bitmap allocator, so that's also good.
There is.
Yeah.
Thanks. There is the cleanup is preparation for something bigger. What we want to do is what we observe is that memory structures used by bitmap area lifts instances are extremely hot. So at the moment, bitmap area leaf aggregates bitmap zones indirectly using std vector. I think that's a tricky part that have potential to disable at least or impose functioning of CPU prefetcher. I want to optimize. I want to embed bitmap zones directly in the leaves.
Cool.
And
okay.
after that, put them on huge TLBs. That's the goal.
Awesome. That sounds great. Okay. The other thing that I've noticed is that you've probably seen it as well. BlueStore is just slow to start because it has to initialize the bitmaps, which are sort of enumerating every bit in the system. And when you run it in dev, it's not that big a deal. But when you run it on an actual disk, that's 5 or 10 terabytes. It takes many seconds to actually start up and initialize everything. So that's probably that path could probably be optimized, I'm guessing too.
I haven't considered that, but it's good information. I will take care of that as well.
Yeah. Okay. Cool. Awesome. Yeah. Glad to see it getting some attention. Let's see other stuff. The fast dispatch stuff merged a while ago. Actually, that might have been before last week. So that's good. It seems to be working fine. We didn't actually measure much of a difference, but the code path is so much simpler and cleaner that I'd have a hard time imagining that it isn't helping somewhat. And let's see, Hamai had a pull request that was trying to optimize the get reserved maps and release maps. He closed that, I think, because it needs some rework, but I think that is something that we want to pursue, having a more efficient path for grabbing references to those maps. So hopefully we'll reopen that later. What else? There's some already made changes trickling in. Let's see, there's a new pull request that adds an interface so you can explicitly control the recovery priority for PGs on a per PG basis. This is sort of meant as a last resort interface in case the automated per pool recovery isn't doing what it's supposed to do or something. And so you have a little bit more control over the system. So that'll likely go in. Let's see, I guess the other main thing that's happening, yeah, I think that's it. That's mostly it for the pull requests. The main one that I've been working on is the BlueStore wall writes, which are horribly named. It's the sort of journal deferred writes in BlueStore. And I made one small change that doubled the IOPS that you'd get when you're doing, like, say, 4K IOs through BlueStore on a hard disk, just by making it not wake up and do a database transaction commit just to clean up the wall record. Just sort of useless work. We might as well just wait until the next commit. So that doubled it. And then I did another series of changes that were not ready to merge, but they would basically batch up those deferred writes until you had n of them and then submit them all in parallel. And that like quadrupled performance on a spinning disk. So it's pretty significant. But in the process of doing that, I was cleaning up a bunch of other things in BlueStore and realized that there's some sort of deeper issues with deferred writes wall stuff. So I'm going to go fix all that stuff first, and then do those flush cleanups and deferred stuff. So that'll have to wait a little bit longer. But the good news is that we went from like 50 IOPS to 400 some IOPS on just a disk, which was nice. So. Yep, I think that's all I have on that front.
Sage, one of the things I'm nervous about with those results, though, is that in the past we've seen better results than that. So for some reason, one way or another, we've done better in the past.
Not on 4K writes, I don't think.
Maybe.
I don't think. Maybe, I don't know. I also tested it with putting the journal on an SSD and using the disk for data, and also saw a corresponding speed up with just the change I have now. It's doing more like 400 IOPS, where you're basically doing a journal on SSD and all the writes going to the disk.
That's on a 7200 RPM spinning disk?
Yep, yeah, it's a WD black, I guess.
your drive shouldn't do that much, so you're seeing some kind of coalescing.
Yeah, I know, exactly. Yep, which is what you'd expect. That's exactly what FileStore will do. So this is just a Rados bench 4K writes. So it's a separate object. So they're all going to the journal, and then asynchronously they're writing to the disk. And they're getting batched up. Basically, the IO scheduler is saying, "Oh, these are all written to adjacent blocks. I'm just going to do one IO, or they're in the same track, or whatever."
How big was
the same thing that FileStore does?
How big was the range that you were writing to?
This is just Rados bench -b 4K, so they're effectively sequential once they actually hit the disk. So it's sort of an easy case in that sense. If you're doing random 4K overwrites, it'll be a little bit worse. But even so, you'll see it'll be better because the sort of the deeper the queue, the more the disk arm is going to be able to schedule. They're all asynchronous, so it'll sort of do as well as your queue allows it to do.
Yeah.
Which is the same thing that you would see with FileStore too, with XFS.
Yeah. You're probably writing to the outer tracks too if you're just doing Rados bench. I imagine.
Yeah.
All right.
But I think the main thing that we can do there that we is basically whenever we have those deferred writes, if we just batch them up a little bit on a spinning disk, it'll help because the disk arm can stay by the journal, and then when it goes and does all the other stuff, it can do it all at once instead of going back and forth. And that seems to make a big difference. It'll take a little bit of tuning to figure out like what the right batch size is and when to trigger a batch flush and all that stuff. But when I rewrite the deferred writes code, I'm going to make sure I structure it so that we can sort of have flexible batching. So we can either flush the batch immediately or batch it up indefinitely or whatever. So the code will be structured so that to enable that sort of policy. So yeah, that'll have to come later, a little bit later. So I'm planning to spend the rest of the week, hopefully, dealing with the deferred write stuff in BlueStore. Let's see, what else is happening on the performance front? Does anybody else have any topics they want to bring up or talk about?
Maybe one related to encoding of extent map. I mean here extent map encode sum function. At the moment, I'm taking a look on perf result. I profiled it for L3 cache misses, and it's responsible for around 70% of that. Right now I'm working on resurrecting your idea for caching blobs. Using a buffer list there is buffer list is too big. We really need to we really need to have the data local, so embedding indirectly some small array of bytes directly to the blob object seems a good idea that would allow prefetcher to do its job correctly.
Is it if you're doing that though, is that going to help with the L3 cache misses? I can see that saving all the varant encoding time, but most of those fields that are in the blob that are being encoded are the fields also in the blob.
It looks that I made that cache right now. Got quite interesting performance bonus. However, what is really interesting are the problems that were unhidden by that. It looks that the compiler has a lot of problems with proper inlining. For example, didn't inline operator on iterator over BlueStore PX and T. Wow, it's responsible for 60% of those 70% of L3 cache misses.
Wow. Okay.
The same we have similar issue we have with decoding some small integers. Basically,
some the varant encode.
Yep, exactly.
So there is a
varint low z.
So my guess is that it's because the current varant has a loop in it, and usually the compiler doesn't want to inline stuff with loops. At least So I've heard, but there was a patch forever ago that just unrolled the loop basically into a bunch of conditionals. It might be that doing something like that will help. It never actually merged. It's open. If you look at the request tagged for BlueStore, it's one of the oldest ones.
Okay, okay. We'll
something like that
take a
might
look
help.
on that.
Awesome.
Cool.
Okay.
By the way, yeah, please continue. Sorry.
I was just going to ask, even though you're seeing all these L3 cache misses, do you actually suspect that that's what is causing a performance impact here?
Yeah.
Like, is it enough to slow it down significantly?
I think that if we eradicate those cache, those misses, we'll be able to move to another bottleneck that I guess will be sending submitting IO requests one per one manner. Basically, this is because we don't support batching in the block device write IO path. Anyway, we already have we are already working on that. We have a pull request, some preliminary pull request, VIP, that brings batching across the whole BlueStore pipeline. However, the part related to IO submit is not ready yet. Anyway, I think that the most painful bottleneck right now is in the front of the pipeline, in the methods that ends in the prepare state. In other words,
BlueStore or an OSD?
BlueStore, definitely BlueStore.
Okay. Which part of? Do you have a sense of which part of prepare? Like all the do right and all the complexity there?
Yeah, something like that. Basically, those guys that are encapsulated in add TXN transaction or something like that.
Yeah, add transaction. Yep. Yeah, I believe that. That's where all the complicated parts are.
Anyway, when skipping those complexity there, RocksDB on my hardware is able to achieve around 70 kilo IOPS using JEmalloc and and when compiled with tcmalloc, I've seen over 100 kilo IOPS. So I guess that RocksDB is not so slow.
Yeah, I think the issues we've seen with RocksDB are less around the commit path and more around compaction. When it kicks in asynchronously, you start having all this background work.
Yeah.
And contention on the device. And then
you can write to the WAL really fast.
Yeah. It's all the deferred work that kills us. But that's good news. Cool. Okay. Well, I'm delighted to see that you're doing this detailed profiling. This is awesome. We're finding all kinds of good stuff. So
nice to hear.
Carry on. Thank you.
Sure. Yet another question, if I may.
Mm-hmm. You just froze.
Okay, I thought it was me. That's good.
Well, we'll sit here in suspense.
In the meantime, Sage,
hello. Radek will continue in a second.
Yeah, sure. Okay.
Hello. Once again, my machine just crashed. Terribly sorry. I'm using Adam's machine.
Hello.
Cool. So it looks that BlueStore data structures, I mean here especially extent map, blobs, etc., are scattered over memory. They are linked to using boost intrusive pointer that, by the way, at least in the development build, not checked on the release one, but definitely in development builds we have assertion in the dereference operator on a boost intrusive pointer. Assertion one test is not so big. However, we have dozens, we have zillions of places where we use it. That's one problem, but I guess it's quite easy to deal with. The second, the the worst case is that we have data structures scattered over memory. I'm working on that. For example, I started using Boost object pool to have extent maps placed in a continuous region of memory. It's already made. I have a patch. I hope I will publish it soon.
Mhm.
However, I have question related to ONode, to blob of ONodes.
Okay.
I would like to put them also on object pool that is coupled with ONode. So the question is, can blob instance outlive ONode? Definitely, definitely this is the case in shared blobs, but ONodes itself. Sorry, blobs itself.
I don't think so. I don't think so. There used to be a case where we carried a reference to a blob ref.
Yep. We have reference counter. We have blob ref, and I'm thinking about eradicating it completely and putting the memory that is used by blob instances directly in the ONode that owns a blob.
Yeah, so it's spanning blob. It's the extent. So the one other place where the reference is in buffer cache right now, right context right now. I guess it's gone. There used to be a reference in the trans context, but that's been removed. So I think we're good. Yeah, it's really just
Great.
the ONode and the extent. Yeah, so if you can just switch those to like unique pointer or something, or just a raw pointer, yeah, I think that would be great.
Just a raw pointer. However, instead of calling new using the system new, using the new from heap, we can try to use placement new on an area that is embedded, that is continuous and embedded directly to ONode.
Okay, and then you just rely on a sparse. You'd rely on a sparse memory space. What happens if you run out of space?
I guess no. Boost has object pools. Basically, it's they are okay. They are slabs, basically.
I see. Okay, got it. Okay, so it'd be a slab per ONode, basically.
Yep. For blobs and extent inside ONode.
Yep, that sounds great. Yeah, let's do that.
Cool.
That sounds like a great idea. And you can probably kill the reference counting on blob too.
Yep. Exactly.
Just have to be a little bit careful because there are multiple extents that refer to the same blob.
Yes, I saw that. I saw that case.
Okay, cool, awesome. Okay.
Hey, Radoslav, do you think you could join the BlueStar stand-up so we could?
Sure, with pleasure.
Fantastic.
Yeah. All right, I'll add you to the invite. Cool. Okay.
Thanks. So I'm starting poking with that. We will need to. I guess we will need to put. We need to overload placement new operator in mempools, but this won't be an issue, I guess. Okay.
Yeah. Cool. Okay. Okay. Yep, that all sounds great. Let's see. Oh, I guess the one other thing I'll mention, this came up, I can't remember if we talked about it here or not, but this came up after the, we must have, with the discussion of, with the Nokia folks, where they were seeing, after when the periodic compaction kicked in, they would see a bunch of random reads, or just reads, I guess, from their RocksDB device. And the speculation was that that was due to not so much not the compaction itself, but the invalidation of the RocksDB cache that results from compaction, because the old SST is thrown away and new ones are sort of populated. And so I have a patch that just introduces this really sort of brain dead write buffer cache to BlueFS, so that it just keeps the last n SSTs that are written in memory, and if you read from them, it'll just return out of memory. I think we haven't sort of, have we, Mark, do we get a definitive answer from them whether that was actually helping or not?
I don't think so. I don't think I've heard anything since you wrote that.
So we're still sort of waiting for that. So there are two possibilities. One is that those reads are from compaction itself, where it's sequentially scanning, or supposedly sequentially scanning the SSTs in order to generate a new SST. And those IOs should be sequential, and hopefully not too painful on the device. Maybe we're not doing read ahead. I guess that's one possibility there where we could fix it. But that's sort of scenario A. Scenario B is that it's this cache invalidation that happens in RocksDB that results in a bunch of cache misses post compaction, and these random read IOs to the new SSTs. And that's what this write buffer would sort of alleviate. So yeah, I guess we're still waiting to find out if it's going to help or not. It might be, Mark, that we need to just reproduce this workload.
Yeah, I was considering
it and instrument it carefully, so we can first reproduce exactly what they saw, where we can actually see the IOs on the RocksDB device, and then dig in and make sure we understand exactly which part of RocksDB is causing those IOs.
I thought they were claiming, though, that they weren't seeing the IOs in the RocksDB device. They were claiming that they saw the IOs on the block device.
The second time around that happened, but that was because they stopped doing the RocksDB device, I think, because we told them they didn't need to have a separate RocksDB device, which is true, but it actually was helpful just to tell what kind of IOs, who's causing the IOs. So
okay,
part of it was just the way that they set up that particular test run.
Okay.
Yeah.
If that's the case, then yeah, that makes more sense. Okay.
Yep. So I think we should do the same thing. So set it up where we're just using a spinning disk. I think that's the case, right? I don't remember if they're using an SSD or not. I guess that part doesn't matter though. But make a big block.db partition on the same disk, just so we can look at block trace and see, or IOTop or whatever the hell, just to see where the IOs are coming from. And when we see those periodic reads happening, corresponding with compaction, then we can dig in and find out exactly what's causing them. So yet another project on your plate.
Indeed.
But we should make sure that remains on the list, because I think that's going to be pretty important for these object workloads. Their workload isn't special at all. It's going to be a pretty common one.
Yeah. In the past, I have seen reads on the RocksDB partition, the DB partition, but I always assumed it was from compaction reads.
Yeah.
So I hadn't looked at any closer than that.
Yeah, I mean, it is kind of, right?
Yeah.
It's the pre and post compaction, I guess. Yeah.
Yeah. If we can make sure that the SSTs are actually cached and not being reread, then that's a win.
That'll help, definitely. Yep. Okay. That's all I have. Oh, it might be worth. Does anybody else have anything they want to talk about? I have one other thing I can mention. We have a periodic call with some folks at UC Santa Cruz who are doing. They're working on tiering, sort of explicit tiering. So they want to build some application that sort of knows what data is going to be accessed ahead of time, and so they want to sort of pre-stage parts of objects on SSD as opposed to disk, so that their computation then runs faster. And their goal is to do that both for parts of objects and for parts of the OMAP key space. So for example, they might be doing a columnar database in OMAP objects and pre-stage certain columns on SSD before their computation runs. But as a result of that, they're talking about extending the Rados interface so that you can sort of pass an explicit hint that says this OMAP key or prefix for OMAP keys should be on a fast tier or a slow tier, and then have BlueStore actually do that, where RocksDB would be smart enough to put those on a different device. So we have a rough plan on how to do that. but right now it's sort of pretty researchy right now. Just want to see if it makes sense and if it'll actually work. But that's one thing that might end up coming down the pike. If there are other use cases where that would be useful, we should try to identify those sooner rather than later and make sure to see if it makes sense to do this, or if there are other requirements beyond what they have that we should take into consideration.
In BlueStore anyway, I mean, I guess I had always kind of assumed that as technology marches on, we're going to see OMAP on some kind of solid state disk anyway. The occurrence of OMAP being on spinning disk is going to be low for most people. Maybe that's the wrong assumption.
Yeah, I think it's sort of a wrong assumption. Because I think it's sort of, I mean, there's a tendency now to like conflate APIs with use cases and therefore with sort of the storage backend. So like object is thought of as big and slow, and block is like small and fast or whatever. But that's not really true. And as the APIs become more broadly adopted, then they'll be used in different ways. So you could imagine having an object store that has bazillions of objects that are super cold. So you have lots of metadata OMAP indexes that are cold. Mm-hmm. And you can also imagine object stores that are very high performance, and so everything would be on solid state. Sort of contrary to either the assumption that some things are slow or some things are fast.
Specifically with OMAP, though, I mean, do you see a lot of use cases?
Yeah, I can see that. Yeah, because you might have indexes for RGW, for example. If you have a huge archive, mm-hmm. then you don't need all those indexes necessarily on SSD. Mm-hmm. Although that's sort of a limited example because the index is going to be a minority of the data set. In their particular use case, they're like most of their data would be in OMAP because it's a database. And so and they would have like column groups effectively sort of stored in OMAP keys.
Yeah.
And the whole point of this is that they would take certain columns so they might have like 100-dimensional or 100-column data set that's like some, I don't know, simulation or whatever. Yeah. And they want to basically stage only those columns for a particular visualization that they're going to be doing and then run it.
Sure.
So anyway.
It strikes me it will work, right? I mean, I don't think there's any reason why it couldn't work. It just seems like you have to, it's real specific.
Yeah. Yeah.
A real specific use case that you're
okay. Well, so the OMAP piece is half of it. The other half it's doing the same thing on the object. So you would say that this range of the object, I know is hot, and I want to hint that it is staged on a SSD or a HDD. And the mechanism we're looking at for doing that is actually just making it so that the IOs that BlueStore generates using the libaio interface can be tagged. We want a kernel interface so that we can tag individual AIOs as hot or cold, so that some underlying cache tier like DM cache or B cache or flash cache can see those hints and put the data directly where it's supposed to go instead of trying to learn it online later. And so that requires some kernel changes because the AIO interface doesn't quite do it, and the cache things aren't looking at per IO hints; they're only looking at process hints. So there's some fix-up that needs to be done. But once all that infrastructure is in place, then we'll have this general mechanism where we can have BlueStore specifically hinting that this should go on flash and this should not, which will be useful sort of in all of the cases for any hybrid scenario.
Sure.
Yep. So anyway, that's, if anybody's interested in that, let us know and we can connect you with those folks. This might be of interest actually to the Intel team because their caching product, as I understand it, has some pretty sophisticated hinting that they sort of kludged together. And I think that's basically the functionality. It probably implements the hinting that we need, except for the AIO interface gap. But that's we want to basically get those hints to be respected by all the different cache tiering things, or at least a handful that people would actually use, because the Intel cache stuff is still closed source, I think. Hopefully not for too much longer. But
Sage, is as long as we're talking about kind of experimental things, I was curious about. I've wondered for a while if it would make sense to have some kind of an OSD that could do some kind of like smart distribution of data across different disks. So instead of using kind of crush to go all the way down to the disk level, you use it to go to a specific OSD, but then in that OSD you make more real-time choices about which disks are busy or not.
Yep, that could certainly be done. That was sort of honestly what I thought was going to happen like 7 or 8 years ago. When we started using Btrfs, you would have an OSD comprised of a whole bunch of devices that Btrfs was pulling together and doing its own software RAID and replication and smart stuff internally. So that could certainly be done. And there's some interesting systems out there that I've seen references to that like take even pretty simple scenarios like a pair of disks or like 3 disks where you sort of chain them together and you use one of them for like the sequential journaling and you use one of them for like the random writes, and you're just doing some fairly basic heuristics about sort of directing different types of IO to different devices when you can, and getting pretty substantial wins.
Yeah. Even with our issues with like scrub and other things, right? I mean, if you can be internally making decisions about this disk is busy doing some kind of repair or something, and other disks can take over for some of the load.
Yep.
And now with
and
like
I think
persistent.
There's sorry, go ahead. Persistent.
I was just gonna. Well, now that we've got persistent fast memory coming down the pipe, it seems like you can actually start doing things like having a really fast database of memory that can keep track of what you're doing.
Yep, and I think there's something to be said too for having local redundancy as well as the sort of Ceph multi or inter OSD redundancy.
Yep.
So if you can do local repair and recovery, then that's a win.
Yeah.
And you can even make the failure domain sort of reasonable too, where you could imagine an OSD that has multiple disks where it tries to keep PGs isolated on a single disk. So if you have a spindle failure, you only lose certain PGs and the others are still intact. You could do things like that too.
Yeah.
Lots of possibilities. But
could you see something like this actually happening inside BlueStore? I mean, is that the place where the new OSD rewrite in BlueStore? I mean, is this something we could be thinking about?
I don't want to think about it yet.
Okay.
But it certainly could. It could be done there. I'm a little bit hesitant to pile in too much into the same layer. So if we can stack on top of a DM, a block target that does this, and sort of have a rich enough set of hints that we can communicate what we need to communicate, that would be preferable, I think. Because otherwise you're creating a increasingly complex monolith. But who knows? It might be inevitable.
As we rewrite the OSD, we should be, if we're interested in this, we should be thinking carefully about it, though. How the threading model is going to work, how.
Yeah. It's already pretty well segregated on placement group, so I'm not sure. It should be fine. I think this part is orthogonal, but yeah. Oh, I guess one last topic. I sent an email to the list last week about the explicit mappings in the OSD map. I just want to call people's attention to it if you didn't already see it. The idea there is to add the ability in the OSD map to have explicit overrides to crush so that you can sort of enumerate the PGs that are not optimally placed by crush and place them optimally. So you get conceivably a perfect distribution of placement groups across OSDs without very much overhead. So hoping to get the infrastructure for that at least in place in Luminous, even if we don't actually have all the smarts to actually sort of generate that distribution. But maybe we can have something simple even to do it. By then we'll see. But that's the variance between OSDs is a big source of performance loss because don't have an even distribution, and so you're underutilizing, you end up bottlenecking on sort of a handful of OSDs. So something to look at. I guess that's it. Any other topics?
I'm sorry, this is Ben. I didn't quite hear that part about the OSD distribution function. Is there something written down about it, or?
Yeah, let me find the email I sent to the list. Ceph, I'll put it in the chat. It was sometime last week. So let me see.
Because I've run into that. When the bigger the scale, the more a problem it becomes.
Yep.
Yeah.
Here, it's the subject. It's in the chat. You can just look. I sent it last Wednesday. And there's a pad with a bunch of notes. And I think I even have a branch that implements sort of some of it. But it's not complete yet.
Thank you.
But sort of the nice thing is, typically people increase the number of placement groups to even out the distribution, which means that having a sort of an explicit mapping is expensive because you have a lot of PGs to enumerate. But if you have this mechanism, then you actually don't need to do that. You can get by with a much smaller number of PGs, in which case the exception table can be quite small.
Totally
Overall,
agree.
I think it's pretty promising.
Thank you.
Yep.
Sage, regarding that, where would you see like a layer living that would try to automatically recreate exceptions for when the topology changes? Like, where would that live?
It would just be a module in the manager.
Okay.
That's just watching the distribution and tweaking it online.
Yeah. So I think we've discussed this before, but the step would be when the topology changes, you kind of map to a non-ideal distribution, which causes data movement, but then you recreate rules on top of that then kind of.
So the way that the remapping is structured, you can make the sort of explicit mappings conditional and on a single OSD, so that you basically say that for PGX, remap OSD1 to OSD4, because I know that 4 is underutilized and 1 is overutilized. And if that PG changes because crush, there's a big topology change and crush is different, then, and that exception doesn't apply anymore, then it just is ignored. So if 1 is no longer, if that PG no longer maps to 1, then it does nothing. So it sort of gracefully reverts to whatever crush is doing, which to a first approximation should be pretty good. So I think it'll be okay.
Okay.
We'll find out, I guess.
Yeah.
And worst case, we could do this sort of synchronously in the monitor also, but that's not going to scale very well to the large clusters. So we just have to be careful.
Yeah. There's no way that we could preemptively create the new rules, like say, this is how the map is going to change. I mean, we can't always do that, but could we say this is how the map is going to change, so create the rules in advance, only do the data movement once.
That's what we do already with prime PG temp. So you could do a similar thing here.
Okay.
And if we did that, then it would live in the monitor. So whatever the code that does it, I think we'll write it in C or C++ and make it a module so that we can sort of run it wherever seems appropriate. But we don't want to. I don't think we should limit ourselves to doing it in the monitor, because for large clusters it might not be feasible.
Does it have to be in the monitor if we do that though?
If you want it to synchronously happen with an arbitrary change, then it kind of has to be, yeah. Because somebody might say OSD out, and that would cause data movement, and you need to analyze what that movement would be and sort of add exceptions before that movement that actually applies.
Unless before you actually did the OSD out, you did other stuff first, right? I mean, you could.
I guess you could have a sort of an up call, I guess, or out to some other module. But the thing is that the concern is that it might be a computationally expensive thing to do that analysis.
Yeah.
And so it's not so much, I guess it's less where, it's when. And doing it synchronously in line with any arbitrary OST map update might not be feasible.
Yeah.
Maybe it is. If the PG counts are small, it might be fine. But
you could do crazy things like pre-cache it, right? Like figure out what rules would need to be done if something were to happen, and then like keep them laying around.
Yes. Yeah. Yeah.
Fun.
Yep. Okay. Anything else? All right. Thanks, everyone.
All right. See you later, guys.
Have a good one.
Thanks. See you.